So in this video, you can have to discuss about how we can be able to differentiate the functions using what we call the chain rule. So what is the chain rule of differentiation? Now, having gone through the product rule of differentiation and also the quotient rule of differentiation, we talk of the constant rule and multiple constant rule, and also some sort of the techniques of differentiation. Now I'd like to venture into what we call the chain rule of differentiation. So what is the chain rule of differentiation if that's the case? Let's say we have a function, let's say given as f of x is equal to, let's say, open bracket, g of x and our overall to the power n. Let's say this is a function f of x. Now in this case, the function is having the outer function, which is the whole of the function with actually a power n, and it also consists of the inner function given as the g of x. So in this case, you have to understand how you can be able to differentiate this one using the chain rule of differentiation. So what is the principle behind the chain rule of differentiation? Now in this case, the f of x prime, which is the derivative of the function, will be given as the n, now g of x, and that to the power n minus 1 times g of x prime. Thus, how we differentiate the function using the chain rule. Now, the derivative of the other function, in the terms the derivative of the inner function, that which is given as that. So this is what you call the chain rule of differentiation. Let's say we have this case. We can also have in this notation as well, if we may think to. We can also, let's say we have f of x is equal to, let's say, a v, let's say to the power n. So in this case, f of x prime will be given as n times the inner function, which is v n minus 1 times the v prime, which is the same as that. So which means the outer function, its derivative, times the derivative of the inner function, the which is given as that. So basically we use actually a chain rule whenever we have a function that which is being raised to somewhat power. Let's say we have, in this case, let's say we have a function f of x is equal to, let's say, x squared minus 1 to the power, let's say, 5. So what is the derivative of this function using the chain rule? So now principle means the same. Let's say we have, in this case, the inner function. Let's say it is given as the v. So we have it as x squared minus 1. And what is the v prime? That will be given as, let's say, 2x. Now what is the formula for actually a chain rule? We'll have f of x being given as, now have it as a v to the power n, and that minus 1 should be this. Now it should be this. So now have n, inner function, which is v to the power n minus 1 times the derivative of the inner function. That will be given as, now have it as 5, and x squared minus 1 to the power now 4 times the derivative of the inner function, which is given as the 2x, of which now this is the same as 10x, and x to the power 2 minus 1 to the power 4. Now that is the derivative in that nature. So that is the derivative of the outer function times the derivative of the inner function, and of which you can see that arbitrarily we are using the power rule whenever we are differentiating the outer function. Let's say we have a function g of x being given as, let's say, the square of should be x squared minus 5x. Now what is the derivative of this function? So principle remains the same. In this case, we should have to rewrite first according to the laws of indices, in the sense that we have g of x now being given as now x squared minus 5x and over the power half. That is the way to go. So what is the inner function? We'll have v is equal to x squared minus 5x, of which the v prime will be given as 2x minus 5. So what is a g of x prime? Now we'll have it as n, a v to the power n minus 1 times, now should be a v prime. In this case, we'll have it as n being given as the power have it as a half, and then a function given as x squared minus 5x, and that to the power now have it as the negative half times not have it as 2x minus 5. So that is the derivative of the outer function. It should be the derivative of the inner function. You should have to understand. And from there we'll have g of x prime, that will be given as, now have it as half times 2x minus 5 in the times now x squared minus 5x to the power negative half. We'll have that and as that. And of which, if we think of, now should be, if we think of expanding this one out, we'll have it as being given as now half times 2x, we'll have it as x, and the minus 5 over 2 can be that. Using the laws of indices, that one is the same as having it as now should be 1 over a square of this expression. So that's the essence behind the actual chain rule for that case. And also, what if we have this case? And also think about this one as well and see how we can be able to have the derivative of the function. Let's say we have a case where we have, let's say, g of x, let's say is given as should be x to the power 5 minus 5x squared to the power, let's say, negative 6. So now what is the derivative of this function? So actually the principle remains the same. We'll have to use the chain rule. In this case, what is the inner function? We'll have it as v is equal to 2x to the power 5 minus 5x to the power 2. And what is the v prime, which is now have it as 10x to the power 4 and the minus 10x. So it should be that. And what is g of x prime? We'll have it as n vn minus 1 times the v prime, that which is the same as now having it as negative 6, now 2x to the power 5 minus 5x to the power 2 the power negative 7, and times now have it as 10x to the power 5, so it should be 10x to the power 4 and the minus should be a 10x, of which you have to now have to simplify further. We'll have it as now negative 6 times this one, we'll have to expand it out. That will be given as, now have it as negative 6 times should be 10x to the power 5, actually to the power 4 minus 10x. So have that as that, and the times what we have it here, which is the same as 2x to the power 5 minus 5 to the power, actually 5 times x to the power 2, and that to the power negative 7. So it should be, of course, we may think of having proper here. Let's have it in a nice way here. So have it as g of x prime being given as, that is negative 6, and I'll have 10x to the power 4 minus 10x, in terms that of now have it as a check to the power 5, and that should be minus 5x into to the power negative 7, and of which we'll have it as g of x prime, that will be given as negative 60x to the power 4, and plus also 60x, that is, and of course, according to the laws of indices, we can have it as divided by now 2x to the power 5 minus should be 5x to the power should be 7. So that is the derivative of that function. And how about if we have this case also? We should also have to get it up to, let's say we have a case where we have it as now, let's say f of x is equal to now the cube root of x squared minus 1. Now what is the derivative of this function? So now first thing you should have to rewrite it according to the laws of indices. That will be now given as x to the power 2 minus 1 to the power actually 1 over 3. and we should be able to have the actual chain in this way. We'll have f of x prime, that will be given as 1 over 3 and x squared minus 1 to the power now 1 over 3 minus 1 times the derivative of the inner function, which is given as the 2x. Now what is 1 over 3 minus 1? So 1 over 3 minus 1, we'll have it as this. Now I'll have 3 here, and I'll have negative here 3, of which you have it as negative 2 over 3. That will be the answer there, negative 2 over 3. That will be the power. Now in this case we'll have it as a 2x over 3 and times x squared minus 1 to the power should be negative 2 over 3. So that is the derivative, of which you can also have it in this case. We'll have it as 2x divided by 3 times now the cube root of x squared minus 1, and that should be to the power actually 2. To the power 2 according to the laws of indices. You can also have that one up to that one as well. What if we have this case now? Now let's say we have this case. We have a function f of x. Let's say it is given as 2x squared minus 1. Let's say to the power 4 in times x plus 2 to the power, let's say 5. So what is the derivative of this function? So now a function consists with the two functions, and that happens to multiply. In this case, we're going to use the product rule. That's the overall differentiation rule. So have it as f of x prime being given as u v prime plus u prime v. Just have to refer to my previous lesson we discussed about the product rule of differentiation. You come across this notation. Now in this case, what is the u? We'll have it as 2x squared minus 1 to the power actually 4. So what is the u prime? Now the derivative of this function will be done using the chain rule. And also what is the v? We'll have it as x plus 2 and that to the power 5. And also the derivative of this function also done using the chain rule. So now in this case we'll have it as 4 2x squared minus 1 to the power 3, the times now should be 4x times 4x, and of which we'll have it the same as, let me just have 2. And now of which we can have it as this case now. By the way, this is to the power 5 here. So now have it as being given as should be 16x, the 2x squared minus 1 to the power 3. So that is the derivative. Now how about the derivative of the v? So now the v prime will be given as, using the chain rule, we'll have it as a 5 and x plus 2 now times actually the power 4 times now should be 1, now which is the same as 5. Now x plus 2 to the power 4. So that is the derivative. Now in this case we'll have to substitute that one now into that formula for the product rule. So that's how the product rule and the quotient rule can be combined, let's say in the given typical problem of interest. You also always have to consider this case as well, and I should have to appreciate. Let's say we have a function, let's say we have it as y is equal to, now should be, let's say 1 minus 2x to the power 4 to the power, let's say 2. Now times the square root of 4 x squared plus 5. Now what is the derivative of this function? Now we have the two segments of the function that happens to multiply. In this case we're going to use the product rule. Now before we do anything, you just have to rewrite the expression. In this case we're going to have that one according to the laws of indices. That will be given as 1 times, okay, 1 minus 2x to the power 4 the power 2 times x squared plus 5 to the power half. Now using the product we'll be able to have the derivative of that function. Try to have that one at your own time, and that is And also, what if we have this case? And I think about this one as well, though you can have to or toggle with actually toggle it out in that way. Let's say we have a function now which is given as, let's say, y is equal to the x plus 1 over x, let's say over to the power 7. So now what is the derivative of this function? So now in this case the overall differentiation rule is said to be a chain rule, where this is the inner function and I will have the whole of this one as the outer function. Now of course there is need of having some sort of rewriting, in the sense that we'll have y is equal to, now have it as x plus x to the power negative 1 according to the laws of indices, and over to the power 7. Now have a chain that will be given as y prime is equal to 7x plus x to the power negative 1 to the power now 6 times the derivative of the inner function, which is given as 1 minus x to the power negative 2. Now that is the given as the. Now in this case we'll have it as 7 minus, now 7 minus 7, that is upon distributing this 7 onto that one. So have 7 minus 7x to the power negative 2 in the terms now at this part. So you have that and as that using the chain rule. And also try to appreciate this problem as well. Let's say we have y is equal to, let's say, y to the power 4. No, should be this x to the power 4, by the way. We have x to the power 4 and our plus 1 over should be x to the power 2 plus 1. Let's say over the power, let's say, negative 5. So now what is the derivative of this function? So now the overall differentiation rule is the overall differentiation rule is the chain rule. So it should be that is the chain rule, in the sense that we'll have this as the outer function, the whole of that one, and we'll have this as the inner function, of which the derivative of the inner function will be done using the quotient rule. So try to have that and out at your own time to have the derivative of that one. And what if we have this case? Let's say we have a function y is equal to, let's say, e to the power, let's say, x squared times, now let's say, a square root of x squared plus 4. What is the derivative of this function? And of course in this case we have two functions that happens to multiply, so in that case we're going to use the product rule, in the sense that we'll have this one as the u, let's say that one as v. In that case we'll have to differentiate this one using the chain rule, as you can see. So try to go through that one also at your own time. Now what if we have this case? Let's say we have it as y is equal to, that should be x minus 1 to the power, let's say, negative 4 and divided by 2x plus 5, let's say, to the power negative should be negative 5. So what is the derivative of this function? And of course we're going to use the overall differentiation rule is given as, now should be a quotient rule, only that this one will be done using the chain rule, and also this one will be done using the chain rule. So I understand you know how to differentiate the function using the quotient rule of that case. So take note of that. And also let's try to go through this example, this kind of equation. I'm very interested in that question. Let's say we have a function, let's say a y is equal, now should be this. Let's say the function should be given as, let's say, g of x is given as, now should be f of x in the times, let's say, a g of x like that, and where f of, let's say, negative 2 is given as 8, and also f of, let's say, a prime of negative 2, it is given as 4. So it should be that. And also f of, let's say, negative 5, which is the prime, is given as 3. Let's say that's the case. And also let's say a g of 5 is given as, let's say, negative 2. And let's say g of 5 prime, that's given as, let's say, that should be a 6. Now the question says that what is the value of f of, now should be, what is the value of a g, what is the value of the g of x prime of the function? Should be g of 5 prime of the function. Should be g of 5 prime of the function. So what is the value of that one? So now, how should you have the solution of this problem if that's the case? So now, first thing, we should have to differentiate the function. And in that case, we are going to use actually a chain rule of differentiation, in the sense that, so now what would be the chain rule of this function? So now g of x prime will be given as, now the derivative of the outer function, which is f of x prime, and times the derivative of the inner function, which is g of x prime. That will be the chain rule of that function. Then I'll have to substitute the given parameters into the equation, in the sense that now we have g of x prime will be now being given as, now have f of x prime. What is g of x? Now we'll have the input of g of x given as the 5. So in that case, we'll have g of 5. That should be that. In the times, what is the input for g of x prime? We also have it as a g of x, a prime. Now should be g of 5 prime. That will be given as that. So now in this case, we'll have it as a g of x prime. That will be given as f of x prime. Now what is g of 5? G of 5 is given as, what is the g of 5? Actually, f of, what is the g of 5 with a smaller g? So we have it as negative 2. So now have it as negative 2 in the terms. What is g of 5 prime? We have it as, should be 6. So have here 6. So take note of that. Then we'll have to substitute these things now. In this case, now have g of x prime will be given as, now what is f of now 2 prime? We'll have it as f4. Now we'll have it as f4 times a 6. That will be given as 24. So now in this case, what it means is that we'll now have it in this case. So now which means we'll have it as g of a 5 prime also been given as the 24. So that's the essence behind that kind of a way out. So now what if we have also this case you should have to understand. Let's say we have the function h of x is now being given as the square root of, should be 4 plus, let's say, a 3 f of x. Now if f of 1 is given as, let's say, 7, and also f of 1 prime is given, let's say, 4. So what is the h of, let's say, a 1 prime of the actual function? So now first thing you should have to differentiate the function. So try to differentiate the function and substitute all the given parameters there, as you can see. Now you'll be able to have that one up to, which is just fine. And also try the following problems at your own time. You should have to try to go through that one. And of course afterwards you're going to apply the chain law in the, let's say, exponential functions, the trigonometric functions, and also some sort of the kind of actually and also some sort of different types of functions you have to come across with. But just have to know that, now let's say we have a y is equal to, let's say, a 1 plus x squared. Should be, let's say, x cubed rather. Let's say we have here as the x cubed. Now what is a tangent line to, let's say, the function of this one at a point, let's say 2, 3. So try to go through that one, though we discussed it before, about how you can be able to have the tangent of a function. And if we have a point in that way, let's say have also f of x is equal to, let's say, x, now the square root of 2 minus x squared. And also try to have the tangent line of a function at a point given as, let's say, 1, 1. So try that one at your own time. You should have to get that one up to. And also try this one as well. Let's say we have this case, you should have to understand. Let's say try to check for this information of this problem. Let's say we have a function, a y is equal, let's say, the square root of 1 plus, let's say, 2x. Now the question says that we should have to calculate the point on which the tangent line to this curve is perpendicular to the line given as 6x and plus 2y, which is equal to 1. Try to search for this information as well at your own time. So that's how that's how the chain of differentiation has to be well understood. So thank you.